Dementia is often described as a disease of memory, a forgotten name, a repeated question, a familiar place that suddenly feels unfamiliar. These are the moments families notice. They're also the moments when most people believe the disease begins. Modern neuroscience suggests otherwise. By the time the first symptoms appear, the brain may already have been changing for 10, 15, or even 20 years. The memory loss people recognize is often one of the final stages of a much longer biological process. That discovery has changed the way scientists study dementia. The focus is no longer only on the moment memory fails. It has shifted toward the silent years before symptoms ever appear. Those hidden years may hold the key to understanding why dementia develops and why protecting the brain could begin long before old age. One of the greatest challenges in treating dementia is that the brain is remarkably good at hiding damage. Unlike a broken bone or an injured muscle, the brain rarely sends an obvious warning signal in its earliest stages. It keeps working. It adapts. It finds alternative pathways. This ability is known as cognitive reserve. Rather than relying on a single route to process information, the brain uses an enormous network of interconnected neurons. When one pathway becomes less efficient, neighboring networks can often compensate. For years, this compensation can hide the effects of ongoing biological change. That is one reason why Alzheimer's disease is so difficult to detect early. Research over the past 2 decades suggests that abnormal changes associated with Alzheimer's, including the gradual accumulation of proteins such as beta amyloid and tau, may begin 10 to 20 years before noticeable symptoms appear. During that time, many people continue working, driving, traveling, and living completely independent lives. Nothing appears unusual, yet beneath the surface, the brain is slowly changing. This doesn't mean everyone with these biological changes will develop dementia. The relationship is far more complex than that, but it reveals something important. Memory loss is not the starting point. It's often the point at which the brain can no longer compensate for changes that have been developing over many years. That single discovery transformed dementia research. Scientists are now asking a different question. Instead of focusing only on how to treat memory loss, they're trying to understand what allows the brain to remain resilient for so long. The human brain represents only about 2% of total body weight, yet it consumes approximately 20% of the body's energy. Very few organs demand so much while weighing so little. Every second, billions of neurons exchange electrical signals. They process vision, language, movement, emotion, and memory almost simultaneously. Even while you're resting, the brain remains extraordinarily active. That activity produces waste, proteins, damaged molecules, and other metabolic byproducts are constantly generated as part of normal brain function. Like any highly active city, the brain needs an efficient cleaning system. For many years, scientists didn't fully understand how that system worked. Then, in 2012, researchers described what is now known as the glymphatic system. Instead of using traditional lymphatic vessels, the brain relies on the movement of cerebrospinal fluid to help clear metabolic waste from its tissues. One of the most interesting findings was when the system becomes most active, not during the day, during sleep. Deep sleep appears to be one of the periods when the brain is most effective at removing waste products, including beta amyloid proteins that have long been linked to Alzheimer's disease. This does not mean that one bad night's sleep causes dementia. The science doesn't support such a simple conclusion. It does suggest something much more interesting. Sleep is not simply a period of rest. It is also a period of maintenance. Every night, while consciousness fades, the brain continues working to preserve itself. That changes the way we think about healthy aging. Protecting the brain isn't only about solving crossword puzzles or taking supplements. Some of its most important maintenance may already be happening during the hours we spend asleep. For decades, dementia was viewed primarily as a neurological disease. Today, researchers increasingly describe it as a condition influenced by the health of the entire body. The brain depends on a constant supply of oxygen and nutrients delivered through an intricate network of blood vessels. Although it accounts for only a small fraction of body weight, it receives roughly 15 to 20% of the heart's blood output. That makes cardiovascular health inseparable from brain health. High blood pressure during midlife has consistently been associated with a higher risk of cognitive decline later in life. Diabetes, smoking, obesity, and physical inactivity have shown similar associations in large population studies. The pattern is difficult to ignore. The same factors that gradually damage blood vessels throughout the body may also affect the tiny vessels that nourish the brain. Over many years, reduced blood flow can place additional stress on neurons that already require enormous amounts of energy to function. Researchers sometimes describe this as a slow erosion rather than a sudden injury. Nothing dramatic happens in a single day. The changes accumulate quietly, year after year. And once again, the brain adapts for as long as it can. But adaptation has limits. By the time memory begins to fail, the biological story may already have been unfolding for decades. When people think about protecting the brain, they usually focus on memory exercises, crossword puzzles, reading, learning a new language. These activities may help maintain cognitive function, but one of the strongest modifiable risk factors identified by researchers has nothing to do with memory itself. It's hearing. In 2020, the Lancet Commission identified hearing loss as one of the largest potentially modifiable risk factors associated with dementia later in life. At first, the connection seems surprising. The ears and the brain perform different jobs. One detects sound, the other interprets it. But the two are inseparable. Every conversation, every piece of music, every familiar voice is processed by complex networks throughout the brain. When hearing gradually declines, those networks receive less stimulation. Communication becomes more difficult. Many people begin avoiding conversations in noisy environments. Some withdraw from social activities altogether. Over time, reduced sensory input and social isolation may place additional strain on cognitive function. This doesn't mean hearing loss causes dementia by itself. The relationship is more complicated than that, but it illustrates a pattern scientists now see repeatedly. The brain does not age in isolation. It reflects the health of multiple systems working together. If dementia develops over decades, then brain health is also shaped over decades. There is no single food, supplement, or exercise that can guarantee protection. No clinical study has demonstrated a way to completely prevent Alzheimer's disease, but research has identified habits consistently associated with a lower risk of cognitive decline. Regular physical activity is one of the strongest. Exercise increases blood flow to the brain and supports the health of blood vessels that supply oxygen and nutrients. Sleep is another. During deep sleep, the glymphatic system becomes more active, helping clear metabolic waste from brain tissue. Cardiovascular health also matters. Managing blood pressure, diabetes, and cholesterol helps protect the delicate network of blood vessels that the brain depends on every second. Social engagement appears to play an important role as well. People who remain socially connected often maintain more frequent cognitive stimulation through conversation, problem solving, and shared experiences. Even continuing to learn new skills later in life has been associated with maintaining cognitive reserve. Individually, none of these habits are extraordinary. Together, they point towards something much more interesting. The brain appears to benefit from the same conditions that support the rest of the body. Healthy aging is not built on one breakthrough. It is built on thousands of ordinary days. For many years, scientists believed the adult brain was relatively fixed. Once neurons were lost, little could be done. That view has changed dramatically. Modern neuroscience has shown that the brain remains capable of adaptation throughout life. This ability is known as neuroplasticity. New connections can form. Existing pathways can become stronger. The brain continuously reorganizes itself in response to experience. This doesn't mean damaged neurons can simply be replaced, nor does it mean neuroplasticity can stop every neurodegenerative disease, but it does change the conversation. Aging is not simply a story of decline, it is also a story of adaptation. Even later in life, the brain continues responding to physical activity, learning, sleep, social interaction, and overall health. That perspective is important because it replaces fear with understanding. The goal is no longer to chase the impossible promise of a brain that never ages. The goal is to support the remarkable capacity the brain still possesses. For generations, dementia was viewed as a disease that began with memory loss. Modern science has rewritten that story. Memory loss is often not the beginning. It is the point at which years of hidden biological change finally become visible. That realization carries an important message. Protecting the brain is unlikely to depend on a single decision made at the age of 70. It's more likely to reflect the cumulative effect of thousands of decisions made across adulthood. The quality of our sleep, the health of our heart and blood vessels, the conversations we continue to have, the movements we repeat every day, the habits that seem too ordinary to matter. Individually, each one appears small. Over decades, they become part of the environment in which the brain either adapts or struggles. Perhaps that is the most profound lesson from dementia research. The brain does not suddenly forget. It changes quietly, patiently, and often invisibly for years before memory begins to fade. Understanding that process doesn't eliminate every risk, but it changes where we choose to look. Instead of asking only how to treat dementia after symptoms appear, we can also ask how to preserve the health of the brain long before those symptoms ever arrive, because the most powerful opportunity may not lie in recovering memories that have already been lost. It may lie in protecting the extraordinary organ that has been preserving them all along.